Hello, good day, and welcome back to Coding with V. And in this video, I want to talk a little bit about module versioning and try to convince you why you really don't have to think too much about it. In episode 5, I show you create like version 2 of your module. In episode 6, this video, I'll dive a little bit deeper and talk a little bit things like sem version and minimal version selection, MVS, which is how Go figure out which modules to pull in to build your software. I'll talk a little bit about that, but it can quickly get into the weeds. While preparing this video, I end up recording a very long video, much longer than I intended, and then losing it. And then I went back and reworked it and tried to see how I can simplify things. And still, it seems like it's just going to be overkill. So I want to convince you that even though I'm going to show you certain things in this video, I'm really trying to talk you out of worrying about it. Like, I don't think the everyday Go developer needs to worry about some of the things I'm going to show you in the video, and I'm going to still try and leave out a lot. So before we jump in, please do me a favor, and if you're not subscribed, please hit the subscribe button. As a content creator, I spend a lot of time trying to get these videos together, preparing slides, that sort of thing. And that's my way of saying that, I really value your attention and I want to try and make videos that are useful for you. I hope that you can return the favor by just taking a minute to go click subscribe and the notification bell so you know when I post videos. And if you don't mind, at the end of the video, if you like what you see, do a thumbs up, leave a comment. If you think I could have done something better, please just leave a comment. All right, with that said, thank you so much. Let's get into it. And so I'm going to come at this sort of backwards, and I'm going to assume that when I say version, that you immediately think of version control and that you understand what tagging mean and branching. If you don't know what that sort of stuff mean, then please just go to ChatGPT or Gemini, or just go online and just do a quick search on version control and tagging. So let's say I have software controls server. It's going to allow me to check in changes to my code. Now, we've seen before that I can have a version control server, I have a user there, and then I could create a repository. And that is just simply a place on the version control server for me to put my code. The version control server doesn't care what I put Go code there, Python, or anything like that. So I just so happen to put Go code in my repository that I create, and it's a go.mod file, so it's a module. From the point of view of the software control server, I can make any number of changes to my Go files. And I might at some point want to say, you know what, there's a special change that I've made and committed, and I want to remember it. And I'm call that, let's say, I'm tag it with this label 0.0.1. I make some other changes. It doesn't necessarily have to be the next change, but some set of changes, and I can tag them accordingly. Again, those different commits or version, I can tag them this way. So I have a module, let's just call it something. And because my tags here are going to allow me to access those Go files, it means that any user, let's say you, who wants to use my module, when you create your Go application, this is on your computer, you create your Go application, and you're going to put in your go.mod file for your application. Remember, every Go application is going to have a go.mod file, right? To manage dependencies. So you're going to put in there that, hey, I want to use Veral's module called thing and version 0.0.1, because that's the feature that you're interested in, or capabilities that that particular version of my module provide. And so what Go is going to do is go to the version server and say, hey, I want to grab the files that are associated with this version. But remember, I said that version was just a tag. From the version control software, it's just a tag. But for Go, it uses that tag to say which version of the module you want. And similarly, if you decide that, hey, you want to use another specific version for whatever reason, you just change the tag. And this is in your go.mod file. We haven't seen this yet. I'm telling you, and then I'm going to show it to you. And so you grab that version. And maybe later on you found out that I created version 2 and you want that. And so you say, you update your go.mod file to say, go fetch that. And that's exactly how you'd be able to say which version of my module you want to use. Now for a second here, I'm going to skip over something that's really important and I'll come back to it later. Let's go to our command line and let's take a look at how this might work. So here I have a Git server. It's not GitHub, but it's a Git server. And I created a repository. So this is me, the user. I created a repository called Awesome. And within that repository, again, I just happen to put Go file. I could put anything. I put some Go files. Now, why did I say that most people wouldn't need to worry about tagging and all this other stuff? Well, because here I've committed a bunch of stuff and I haven't tagged it. And now let's go to my directory here and see what I have. So within this directory, I have two other directory, one called my app one very creatively and my module. You could guess what those do. And if I just do tree and I list it out, you'll see that my app is just a main.go file with its own go.module. So I'm pretending to be you, that user that I mentioned that have a go.mod file that's going to point to my module, and you're going to use it in your main application. And then here's the module that sort of represents me developing it. And so if I go over to this go.mod, you can see there's nothing here yet. And in my Go program, I'm saying I want to go to, this is where my module is stored. And so you, the user, is saying, hey, I want to use this awesome module from Vero. And of course, you have to be able to pull it in. So if you say tidy, it's going to go and fetch it. And notice it says required. And of course, require this module, because that's what the Go program need, your Go program need. But notice how it has this very weird version here, v00.0. And that's because Go is using a pseudo version. Now I'm going to get back to this, but just note that I didn't have to really tell Go which version to use. It just went out and grabbed the latest from the repository, and it happened to be this one with this hash. So Go has created a pseudo version. And if I go back here and I go to my application and I do go run, you'll see that it runs just fine. And I can prove that it's actually pulling and using that, because if I updated this code to say, let's use the value 53 instead, and I go here and I see do a git status, you can see it told me I thought that file changed, and I could do git check-in and I'll do update 3, and then I'll do git push. And if I push that, and then of course if I rerun now, my application is already built for the one with 42, right? I'll have to upgrade. So if I go back here, I can do check for updates. And if I click this, after I click check for upgrade, I see this message. And it tells me that basically this module can be upgraded. So an upgrade is available. So then I can say upgrade direct dependencies, and then notice how it upgrades to 5B, which which would be the most recent version of our module. And so now if I rerun my command, you can see that changed. So it went and got the update. So this is why you really don't need to worry about tagging, because if I was developing this module and you are using my module, the only thing you need to do is check for updates from time to time. And if there's a new update, decide whether you want to upgrade your direct dependencies or my specific dependency on that specific module, and everything is fine. Go is going to keep this pseudo version for you. So what happens once you introduce like tagging or something like that? Well, It just means a little bit more work for the module developer. But again, if this is what the module developer wants to do, that's fine. But I'm saying that you, every day using Go, you don't need to do this. So let's say I wanted to do that. So then I can say git, and I can say tag. And so now if we refresh, we see we have 2 tags, and you can see they correspond to those commits that we were using before. So if I go back to my code here, I can remove this and instead say that, oh, this is version 1.0.0. And if I do git mod tidy, it should update everything. So let's do that. Let's do check for upgrade. There shouldn't be any upgrades because nothing has really changed. And yeah, it's check-in. All right. And so I think we're good. So let's check and see if this actually works. So if we can get this working with tags. So again, this should be our latest version. This should work. And if we want to go back to a previous version, remember we have a version 0.0.1. So I should be able to go back to version 0.0.1. Not git mod, go mod tidy. And so it should download v0.0.1. Now the reason why it's downloading it because remember we didn't had this tag before. So so let's see. Download complete. So clear that. And then if I do go run, and if I run my program, now we're back to 42. If you were using a module that you were creating for your application, do you really want to do go through the headache of adding tags? All you have to do is make changes, commit them, and then when you want an update, just do check for update or just go straight to update direct dependencies, okay? And you're good, and you don't have to worry about it. This is what I'm saying that this is an overkill. So what happened if you did like a version 2 of what we created before? Well, if you created a version 2, we know that that just simply means that you put /v2 at the end of your module name. So now that new tag is available. And all this that I'm doing, this is why I said this goes off into the weeds. So anyway, so we have a version 2, right? All right, cool. Oh man, I'm so trying to make this simple, but I'm failing at it. So okay, so let's say we wanted to use version 2, 2.0.0. Now remember, for version 2, we had to use v2. This is because of how Go treats anything beyond version 1. So anything that's version 0 and version 1, notice we could have still used it without putting like v1 or v0 here. But once you go to version 2, you have to use like v2 and it's going to be the same for v3. That's in the documentation. I can try and show you where it is, but if you're reading the Go module docs, you will see. I need to say I'm using v2 here. Once I say use v2 there, hopefully it's updated. So let's go back here. I'm gonna go mod tidy. Let's see, it should download v2. It did really quickly. Let's clean up, do go run, and we should see 101, which it is. So that's fine. So now you can see, even though I'm developing the module and using it here, I'm pretending like if it's somebody else's module I'm using, and we can see that it's pulling it there. Now, here's how you know that that's what's happening. Let's just say I change the module locally. Let's say I make this, let's say 73. Okay. Now I can still commit the changes, but I'm not even going to push it up to the server. So one of the things that I can do, and let's zoom in here, is we've been talking so far about this go.mod file and how it manages your dependency for your Go program, right? So one of the things I can say is I want to replace this Go version 2.0 with something else. What is the something else? Maybe something that's running on my computer. In this case, I want to replace it with the module that's on my computer that I haven't committed yet. Remember, the one that I have on my computer, I'm using, it has, it's using the value 73. So I want Go to use that local value version. So you can type the replace directive here. So this is a require directive. You can have a replace directive, all this other stuff. You can have a exclude directive. We didn't talk about all that just yet, and still taking a long time here. So let's do that real quick. So you can do go, and if you do help and mod, and you do edit, for example, to get help on, the edit command for go.mod, it tells you all about replace and so on exclude. And so if you do go.mod edit and you do -replace, and you say what's the old module you want to replace and the version for it equal whatever that new module and its version, Go will then use that instead. And if you leave out the version for the new module, then it must be a module root directory. So what that means is that we can say go.mod edit -replace, and we can say we want to replace which thing. If you leave out the version, it just means to replace everything. And I want to replace it with what I have running on my computer. So what I have running on my computer is I'm in the temp directory. All right, it's happy now. I have to give the absolute path. And so now if you go here, you can see it says, while I require this, it's being replaced by this local file. So now if I go back and run my application here, so if I clean this up and run it, go run, we should see that I get 73 now. Yep, and there you go, 73. So that is how you use replace. Now, let me try and wrap this up really quickly because this is taking forever. So going back here, if we go to the Go module documentation, you'll see that there are all these commands. I just showed go edit, but and go tidy. You saw me use that one before. We would go init to create our module. And then there are these directives. The required directive you saw, how to say which thing you're depending on. And then they have the replace directive, exclude. So replace directive, we just saw how we use that. You can read up on that here. And there's the exclude directive for if you don't want to use something. So that's replace and then exclude if you don't want to use something. So what does all this have to do with? We have all these different ways of telling Go which module we want to use, but how does Go really decide, like, this minimal version selection? So before I get into that, let's go back to our slides. I need to show you real quick what is semantic versioning. So if you don't know what semantic versioning is, here's a quick overview of semantic versioning. But if you want to learn more, definitely go to the Semver website. You might hear semantic version being called just Semver, or just look online for other people who've covered it. But really quickly, what it is just a way of being able to come up with a version number that tells you sort of immediately, like, what has changed. So semantic versioning has these parts. It has major, minor, patch, pre-release, and build method, and it sort of have this format. And so major would be for breaking changes. So when I have my module at version 0.0.0, if I make any change that is incompatible in my module, I should create a new version that is a major version, which increment that first number. So far, what you saw was the version I created just uses these first three parts, because those are the required part. These other two are, optional. Minor is for non-breaking changes. So let's say in my module, I added more functions, but I didn't change any of the existing one. That's non-breaking changes. I just give you more features or something like that, but nothing changed. If, on the other hand, I changed the return type or parameter for some existing function, that's a break and change. or I remove something completely, that's a break and change. It means that you cannot use my module anymore. So I should signal that by increasing the major number. And patches, if I just make bug fixes, but I didn't introduce any new features, well, then that's just a patch. And so I increment the patch number. So immediately with these 3 pieces of information, you can tell when a new module has just bug fixes, whether it introduced something new, but it's non-breaking, or whether it introduced something new that is breaking. And then there are other fields that I can add, like this release candidate. So before I actually say I have version 1.0.0.0, I might say I have version 1.0.0.0 dash release candidate 1 or dash beta or dash alpha or anything like that. And on top of that, even with a pre-release, I can then even further. So I can say that, oh, I built it on a specific date or something. And that's why we saw when Go used the pseudo version, it had the commit hash, with like a date, and the version it used was 0.0.0. So let's take a look at some example. So remember I said that, the pre and metadata is optional, just major, minor, and patches required. So if I see 1.0.0, well, we know that's like the first version. And if I do 1.0.1, well, just tell me that some bugs was fixed in that previous version. Again, this is just signaling that some bugs was fixed. If I do something like this, 1.1.0, I'm saying, oh, I have some changes, maybe new capability, a new function was added, things were added, but it's not incompatible. So you know very well that you can upgrade without breaking your application. And again, here, I'm just saying that, oh, I fixed bugs in this 1.0 or the previous release of this. Once I go to 2.0, now I'm saying that, hey, there's some breaking changes here. Maybe I've removed things, whatever it is, you can no longer rely on whatever you had here before. Notice if somebody start using my module at 1.0, they can go straight to using 1.1.1 and still wouldn't experience any break-in changes. They can possibly see new capabilities, but the application is not going to break. But if they try to go from any one of these ones to this 2, it's almost guaranteed that something is going to break. That is why we use the 2, we increase the major number, because we want to say that there are break-in changes. And of course, like I said before I actually release 1.0, I might say, oh, I have 1.0 alpha as a pre-release candidate, right? And then I might say that beta to sort of signal that, oh, this yet still pre-release. Even when I'm doing before my 1.0, I can do things like RC. My CPU say alpha, beta, or RC.1, RC.2, RC.10, and so on. And then, of course, you can put the extra metadata. All right, so hopefully this is a quick introduction to Semver. And now you understand when we use the V0 with the semantic versioning, now Go has an idea of really understanding whether the version is updated or not. And then in the absence of an actual version, it creates a pseudo version so it can still do the same thing. So what is Go really doing? Well, let's now go back real quickly to the documentation. So remember I said that Go uses minimal version selection. What is that exactly? Well, basically, if your main application is using, let's say, several modules, and let's say it's using module A and it's specified in the go.mod file that it wants A at version 1.2, right? But we're going to simplify it here to just 2 numbers instead of remember, semantic version is minimum of 3, right? But let's keep it simple. So we're going to say that your thing is using A at version 1.2. It's also using some other module B at 1.2. But indirectly, that A module is using wants to use module C, and it's saying that it needs C at 1.3. B is saying I'm using module C, but at version 1.4 is the minimum. That's what the author of module B has specified in their .go.mod file. So then module C is using, some other module D at 1.2. So what the dark outline shows you is that Go will select these modules to build your application. And the reason why I would select C 1.4 is because that's the minimum version required by like module B over here. And because 1.4 is compatible or still compatible with 1.3, with 1.3, because remember, this is not incompatible changing going from 1.3 to 1.4. So it can totally use C.1.4 to build against this dependency of A wanting a C module. So you can imagine if B at some point says, oh, you know what, I need C to be 1.9. We can still build our application because that 1.9 would still satisfy the dependency for A because it's not incompatible. All right, and so that is how the minimum version selection happened. And here you can see when we use something like replace. Similarly, you can say I want to exclude. So if let's say you found out that there's some really big issue with module C at version 1.3, you can say exclude that. So again, we can go on and on here. And like I said, you do not need to do this. I really want to drive home the point that you do not need. It's good to kind of know this, but it's really too much for you to do every day. I use Go in and out for years, and I really don't have to do any replace. I don't have to tag my stuff because I'm just building stuff for myself. I wanted this video to be short. It isn't, sorry. Like I said, this is a lot, and I tried different ways of simplifying it, and I would have to break it up at these arbitrary points to say, okay, let's continue, and I didn't want to do that. So hopefully this really explains some of the things to you and convinces you that while it's great to know it, don't worry about it. All right, take care. Thanks. See you in the next video. Bye.